Apollo 12, November 20th, 1969. The mission is over. The crew has returned to the command module. The descent stage of the lunar module is still on the surface. The ascent stage, the upper half of the lander, the part that brought Pete Conrad and Alan Bean back to orbit, is now being guided by remote control toward the lunar surface. This is not an accident. This is an experiment. NASA engineers have calculated the impact trajectory precisely. Seismometers placed on the surface by the crew during their moonwalks are waiting. The ascent stage impacts the surface at a calculated velocity. The seismometers begin recording. What happens next is documented in NASA's own published reports. The preliminary science report for Apollo 12, NASA document SP-235, describes the result. The moon continued to reverberate for approximately 55 minutes following the impact. 55 minutes. The language NASA scientists used when describing the event to the press was exact. They said the moon rang. Like a bell, that description is not from a fringe publication. It is from the men who built the instruments, ran the data, and wrote the reports. The moon rang like a bell for 55 minutes. Here is the problem with that. A solid rocky body, which is what every standard model of the moon describes, does not behave this way. Seismic energy in a dense geologically differentiated solid body attenuates rapidly. Earth produces seismic signals lasting seconds to minutes depending on the magnitude of the event and local geology. 55 minutes is not a longer version of that. It is a different category of result entirely. The official models predicted dampening. They got resonance. That result is in the published NASA record. You can read the document. The explanation for why a solid rocky body with the moon's known density and composition would reverberate for 55 minutes is not in that document. It was not published in the subsequent literature in any form that resolved the discrepancy cleanly. The measurement exists. The explanation for the measurement does not. I want you to sit with that for a moment before I show you what came next. NASA did not repeat the Apollo 12 seismic experiment once. They repeated it 4 more times across the Apollo program. Each time the result was the same class of anomaly. Each time the anomaly was recorded, published, and not explained. April 14, 1970, the Apollo 13 mission has just been aborted following the oxygen tank explosion that nearly killed the crew. But before the mission ended, NASA had already committed the Saturn V third stage, the S-IVB, a booster section the size of a 10-story building, weighing roughly 14 metric tons, to a deliberate impact with the lunar surface. The impact proceeded as planned even as the crew was fighting for their lives on the return journey. The seismic result was recorded by the instruments Apollo 12 had left behind. The moon reverberated for 3 hours and 20 minutes. That figure appears in NASA's published seismic data on the Apollo 13 impact event. 3 hours, 20 minutes, not 55 minutes, 3 hours and 20 minutes. A solid rocky body, even a very dry and fractured one, does not sustain resonance for 3 hours and 20 minutes from a single impact event. Nothing in the standard geophysical model of the moon accounts for that number. The number is in the record. The model has never caught up to it. February 1971. Apollo 14, another S-IVB impact, another controlled seismic test. The reverberation lasted approximately 3 hours. And through Apollos 15 and 16, the seismic network, now expanded to multiple stations across the lunar surface, continued recording. The pattern across all of these measurements is consistent. The moon does not respond to impact the way a solid rocky body should respond. The reverberations are longer, the resonance frequencies are different from model predictions, and the energy dissipation curves do not match anything in the standard geophysical literature for a dense solid sphere. This is not one instrument malfunction on one mission. The ALCP seismic network operated across multiple stations deployed by different crews, calibrated independently. The pattern holds across 5 missions. The same anomaly documented each time. The ALCP network was active until September 1977 when NASA made the decision to terminate it. No replacement seismic network has been placed on the lunar surface by any agency since. The most sensitive seismic data ever collected on the moon was shut down 47 years ago. No follow-up network has been commissioned. That is the NASA record. Before I introduce any outside interpretation, I want to be clear. Everything I have described so far is in the published literature. The data is public, the anomaly is documented in NASA's own reports. The absence of resolution is a matter of the scientific literature. It is not a matter of my interpretation. The explanation for the reverberation pattern has been debated and adjusted in subsequent decades. It has not been resolved. There is a second anomaly from the Apollo program that runs parallel to the seismic data, and it comes from an entirely different instrument. It comes from the samples. Beginning with Apollo 11, astronauts returned lunar rock and soil to Earth for analysis. Over the course of the program, 382 kilograms of lunar material were collected across 6 landing sites. These samples have been studied by hundreds of independent research teams worldwide for over 50 years. The results are published and publicly available. One result appears repeatedly across independent analyses and has never been satisfactorily explained by the standard model of lunar formation. Lunar mare basalts, the dark volcanic rock that makes up the large flat regions of the near side, contain extraordinarily high concentrations of refractory metals, titanium in particular. Also chromium, yttrium, zirconium. These are elements with extremely high melting points, elements that under standard planetary formation processes tend to concentrate in a planet's core, not in its surface crust. In lunar mare samples, titanium concentrations reach values between 6 and 12% by weight in some specimens. Earth's crust, by comparison, averages approximately 0.5% titanium. The difference is not marginal. It is a factor of 12 to 24 in the most anomalous samples. This was not discovered by fringe researchers. It was published in the journal Icarus in the early 1970s by academic teams analyzing the Apollo samples. The anomaly is in the peer-reviewed literature. The samples are in the archive at Johnson Space Center and have been independently verified by researchers on multiple continents. The standard explanation for the Moon's composition is the giant impact hypothesis, the widely accepted model in which a Mars-sized body called Theia collided with the early Earth approximately 4.5 billion years ago. The debris ejected by that collision coalesced to form the Moon. Under this model, the Moon should be composed primarily of material from Earth's mantle, with some contribution from the impactor. High concentrations of refractory metals in the surface crust are not a predicted feature of this formation pathway. But the composition anomaly is not the deepest problem with the giant impact hypothesis. The deepest problem is isotopic. When you analyze Earth rocks and lunar rocks for their oxygen, silicon, chromium, and titanium isotopic ratios, the specific proportions of different atomic variants of each element, you find something unexpected. The ratios are nearly identical. Earth and Moon share isotopic signatures so close that they are essentially indistinguishable by current measurement methods. This is a problem for the model. In standard giant impact scenarios, the Moon forms largely from the debris of the impacting body, Theia, which would have had a different isotopic composition from early Earth, because it formed in a different part of the solar system. If Theia's composition was different, the Moon should reflect that difference in its isotopic ratios. It does not. The Moon's isotopes match Earth's almost exactly. This discrepancy between the predicted and measured isotopic composition of lunar samples is acknowledged in the current scientific literature as an unresolved problem with the giant impact hypothesis. It has been the subject of multiple peer-reviewed papers attempting to modify the model, adjusting Theia's properties, adjusting the dynamics of debris accretion. None of the modifications have produced a clean solution. The giant impact hypothesis remains the consensus model. The isotopic problem it contains remains open. The seismic anomaly asks, why does the Moon resonate like a hollow body? The composition anomaly asks, why does the Moon's surface contain concentrations of refractory metals that no standard formation process produces? And why does its isotopic signature match Earth's when the formation model says it should not? These are two separate questions, from two separate instruments, pointing at the same gap in the official account. Now I want to tell you about a set of transcripts that were classified by NASA for 40 years. The Apollo 10 mission, May 1969, was the dress rehearsal for the landing. Everything was done exactly as it would be done 2 months later for Apollo 11, except the crew did not land. Commander Thomas Stafford and lunar module pilot Eugene Cernan descended to within 14 kilometers of the lunar surface, conducted the maneuvers, then rejoined Command Module pilot John Young in orbit and returned to Earth. At one point during the mission, all 3 astronauts were on the far side of the Moon, behind the lunar body out of radio contact with Earth. The mission recorder continued running. What the recorder captured is documented in the mission transcripts. The crew heard something. They described it as music, not radio static, not mechanical noise from the spacecraft. Music. The specific phrase in the transcript, attributed to Cernan in the published record, is outer space-type music. They discussed it among themselves. They discussed explicitly whether to report it to mission control when they came back around to the near side and regained radio contact, or whether to say nothing. That conversation is in the transcript. They were not released to the public for 40 years. They were declassified in 2008 and are now available through NASA's archive. You can read them. I want to dwell on what that classification represents. The Apollo 10 mission transcripts are, in large part, routine mission documentation, radio communications, system status reports, navigational data, the kind of material that, in normal circumstances, would be declassified as a matter of course once it no longer had strategic value. The classification of specific content within these transcripts was a decision. Someone determined that what was in them warranted restriction. None of the 3 Apollo 10 crew members, Stafford, Young, or Cernan, gave a detailed public account of what they heard on the far side during the 40 years the transcripts were classified. John Young flew on 5 space missions, walked on the Moon on Apollo 16, commanded the first space shuttle flight, and accumulated more time in space than almost any person in history. He died in January 2018. He did not elaborate publicly on the far side recordings. Thomas Stafford commanded 4 space missions, led the Apollo-Soyuz docking in 1975, and rose to the rank of 4-star Air Force general. He has not elaborated. Eugene Cernan was the last human being to walk on the Moon, the commander of Apollo 17, December 1972. He gave hundreds of interviews over the following decades, becoming one of the most publicly present figures of the Apollo era. He was, in later years, asked about the Apollo 10 transcripts in contexts where their contents were available. His response, consistently, was to characterize the sound as interference between the 2 spacecraft's VHF radio systems. That explanation was offered. It was not expanded on. Cernan died in January 2017. He was 82 years old. NASA's official explanation for the Apollo 10 sound is the same explanation Cernan offered. Interference between the lunar modules and command module's VHF radio systems creating a beating frequency perceived as tonal sound. That explanation is technically possible. VHF radio interference can produce tonal sounds under certain conditions. What it does not account for is the reaction of 3 experienced test pilots who collectively had thousands of hours in complex aircraft and spacecraft. Men who had been trained to identify and troubleshoot exactly this category of equipment anomaly. Men who, on hearing what they heard, did not log it as radio interference. They discussed, on the record, in the mission transcript, whether to disclose it to mission control at all. Experienced aviators do not deliberate over whether to report radio noise they recognize. They troubleshoot it, they note it in the log, and they move on. 3 astronauts explicitly debating whether to tell mission control what they were hearing is not a response to a recognized technical artifact. That debate is documented. The explanation for why it happened, in the words of the 3 men who had it, was classified for 40 years and has not been given publicly since. The transcripts are on NASA's website. The discussion is in them. You can read it yourself. What you will not find in any interview, press conference, or memoir published in the 55 years since that mission is a detailed explanation from Stafford, Young, or Cernan of what they actually believed they heard on the far side of the Moon in May 1969. Cernan's version, radio interference, is on record. His elaboration of why 3 career aviators found radio interference worth debating whether to disclose is not. That statement is followed by silence. The silence is in the record next to the transcript, and the transcript is in the record next to no explanation. In 1970, 1 year after Apollo 11, 2 Soviet scientists published an article in the state publication Sputnik. Their names were Mikhail Vasin and Alexander Shcherbakov. They were members of the Soviet Academy of Sciences. Their article was titled Is the moon the creation of alien intelligence? That title sounds sensational. The argument inside the article is not sensational. It is methodical. Vasin and Sherbakov were working from the same seismic data NASA had published. Their argument followed the data, the reverberation patterns documented by the Apollo seismometers, the durations, the resonance frequencies, the propagation characteristics were inconsistent with a solid, rocky body. Those patterns were, they argued, more consistent with a hollow body with a high-strength outer shell. Their article was not published in a tabloid. It was published in a Soviet state publication. Vasin and Sherbakov were institutional scientists with documented academic affiliations. The piece was reviewed and approved for state publication in a country where scientific publishing was under the direct oversight of the Soviet government. Scientific work that contradicted official positions did not appear in Soviet state publications without institutional sanction. The Soviet government in 1970 approved the publication of a scientific argument that the moon might be a hollow artificial structure based on NASA's own seismic data. NASA did not publish a formal response to Vasin and Sherbakov. The article has been cited in subsequent literature, largely as a historical curiosity. It has not been formally refuted in the peer-reviewed literature. The specific seismic evidence on which Vasin and Sherbakov based their argument has not been explained in a way that makes their interpretation unnecessary to consider. The Soviet lunar program, which had landed unmanned spacecraft on the moon successfully, conducted the first high-resolution surface imaging and was advancing toward a crewed landing attempt, was quietly wound down following Apollo 11. The crewed program was canceled without a public technical explanation proportionate to the scale of its discontinuation. The Luna unmanned program continued and returned its last sample with Luna 24 in 1976. After that, the program stopped entirely. No Soviet cosmonaut ever attempted a lunar landing. No Russian mission has attempted one since. The Soviet Union had more geopolitical incentive to investigate lunar anomalies than any institution in history. If NASA's data contained evidence that the moon behaved in ways the standard model could not explain, the Soviet scientific establishment had every reason to pursue that evidence and every capability to do so independently. They had their own seismic instruments. They had their own sample analysis program. They had their own political mandate to find anything in the Apollo record that could be exploited on the world stage. Their scientists published the hollow moon hypothesis in a state-approved publication. Their program ended. 2 adversarial governments, 2 independent programs, the same object investigated, the same class of anomaly encountered in the data. The same outcome, both programs stopped, neither returned, neither published an answer to the questions their own instruments raised. The parallelism between those outcomes is not explained by the end of the space race. The space race ended as a geopolitical competition. The moon did not change. The seismic questions the Apollo network raised in 1969 are the same questions sitting in the public record today, 54 years later, unanswered. Neither program returned to generate the data that would answer them. I want to be fair to the mainstream scientific position, because the mainstream position is not unreasonable as far as it goes. The standard explanation for the anomalous seismic reverberation duration is this: the moon's crust is extremely dry and highly fractured. Unlike Earth's crust, which contains significant quantities of water and other fluids that absorb and attenuate seismic energy, the lunar crust is essentially anhydrous, dry at the mineral level in a way that Earth rock is not. In a dry, fractured medium, seismic waves scatter repeatedly rather than being absorbed. The energy bounces, propagates laterally, and dissipates far more slowly than in a fluid-saturated medium. This, the standard model proposes, is why the reverberation lasts longer than expected. That explanation is coherent. It is based on real physics. Dry, fractured rock does transmit seismic energy differently from wet rock. The absence of fluid attenuation is a genuine factor. What the explanation does not account for is the specific duration and resonance quality of the signals actually recorded. The dry, fractured crust model predicts longer reverberation than Earth, perhaps several minutes. Producing 55 minutes or 3 hours and 20 minutes at the observed frequencies requires significant additional modification of the model. Those modifications, involving specific fracture density distributions, specific scattering parameters, specific subsurface depth profiles, have been proposed in the literature. They have not produced a clean, independently confirmed match to the observed data. The model has been made progressively more complex in order to approach the data. The data has not been explained by the model in a form that the scientific community has accepted as settled. The definitive test of the dry fractured crust explanation would be a controlled subsurface seismic survey of the Moon using modern equipment, the kind of survey conducted routinely on Earth to map subsurface geology for engineering and resource work. Applied to the Moon, this technique would distinguish between a dry fractured crust with the scattering characteristics the model requires and a body with different internal structure. It has not been conducted. No seismic instruments have been placed on the lunar surface since the ALSEP network was terminated in 1977. The data that would settle the question definitively does not exist because the investigation that would generate it has not been commissioned by any space agency in the world. I want to be precise about where I am landing because precision is the only thing that matters at the end of an argument like this. 1. I am not telling you the Moon is hollow. The seismic data is anomalous relative to the standard solid body model. That documents a discrepancy. It does not prove a hollow interior. The discrepancy exists. The explanation for it does not, in any form the literature has validated. I am not telling you NASA made contact with extraterrestrial intelligence during the Apollo program. Eugene Cernan, John Young, and Thomas Stafford heard something on the far side of the Moon that they discussed, on the record, not reporting. That discussion is documented. Its explanation, from the men who had it, is not in the public record. I am not telling you the Moon landing was faked. That is a different argument, and it is not one I am making. The argument I am making depends on the missions having been real. The seismic instruments the Apollo astronauts deployed were real. The data they produced was real. The anomaly in that data is real and documented. What I am telling you is this. NASA's own published seismic reports across 5 missions document reverberation patterns inconsistent with the standard model of a solid rocky body. The published attempts to reconcile those patterns with the standard model have not produced an accepted solution. The seismic survey that would resolve the question has not been conducted. 2 Soviet scientists, working from the same published data, argued in a state-approved publication that the evidence was more consistent with a hollow structure. Their argument has not been formally refuted. Their program also ended. The Apollo 10 mission transcripts were classified for 40 years. When released, they documented 3 of the most experienced aviators in history treating an unexplained sound as anomalous enough to debate whether to disclose it. The official explanation for that sound is radio interference. The explanation for why 3 expert test pilots responded to radio interference the way the transcript records them responding has not been published in any form. The lunar composition anomaly, titanium concentrations 12 to 24 times greater than Earth's crust, in a body whose isotopic signature matches Earth's in ways the formation model does not predict, sits in the peer-reviewed literature as an acknowledged open problem. No formation model published since has resolved both of those constraints simultaneously. Eugene Cernan was the last human being to walk on the Moon. He left the surface on December 14, 1972. No human has returned in 52 years. He died in January 2017 without having publicly explained what he heard on the far side of the Moon in May 1969, beyond the characterization of radio interference that he offered once and did not expand upon. Whatever he knew about that sound, he carried it. The transcript of the discussion he had about it, over the far side, out of contact with Earth, in the middle of the most watched technological competition in human history, is available on NASA's website. His elaboration of it is not in any public record. The Apollo 12 Preliminary Science Report, NASA document SP-235, is available through NASA's Technical Reports server. The seismic result it contains 55 minutes of reverberation from a controlled impact on a body every standard model describes as a solid rocky sphere is in that document. The seismic result from the Apollo 13 S-IVB impact is in NASA's published data, 3 hours and 20 minutes. The explanation for why a solid rocky body produces those numbers is not in either document. It has not been published in any validated form in the 54 years since the instruments recorded it. The instruments that would have continued generating data toward an answer were shut down in 1977. No replacement has been placed on the surface since. The question the Apollo seismic network raised is the same question sitting in the published record today, in documents that anyone can open and read. That data is 54 years old. No human has returned to the moon. The question the data contains has not been answered. I find that difficult to explain.